Good morning, everyone. So, today we are going to start with the second chapter of distributed computing, that is communication in distributed systems. So, firstly, we will see what is meant by communication and why it is essential in distributed system. So, moving to the fundamentals, that is why communication. So, in distributed system, as we know, many computers are connected together and they share the information as they need to execute the program, or they need to carry out or to execute the tasks. They need to share the informations as these many computers, number of computers, are having their own CPUs and own local memory. So if any user submits his task on one machine for the execution, it may get migrated to another machine, or data may get transferred from one machine to another machine for the execution. So this is what the basics of distributed system. So to migrate the task or to share the information, what is required there? Communication is required between two systems. So that we are going to why that communication is required. So to execute the task, entity means the computers which are present in the distributed system, they need to share the information within the entities. So and this is what the communication is required. So for example, suppose the climate control system is there. So climate control system may have many units there in the system. So one unit may be temperature sensor, who is going to, or which is going to sense the temperature, and after sensing that temperature, that information means what is the temperature, what is the current temperature, that information should be shared to the control system, right? So now this is what the information transfer. So basically, if collective number of units are there in any system which is collectively representing single system, the communication, or we can say the sharing of information, is required between the different units of the system. Okay, so the processes run on the different machines, and the applications are implemented by the processes might include the communication between them. So one process may be running on different machines, so we can say the communication is required between these machines or the applications. Now next is the types of communications in distributed system. So basically this is types of communication we are going to see in not only in distributed system, in overall computing system. Okay, so first is a unstructured communication and second is a structured communication. So what is mean by unstructured communication? So unstructured communication uses shared memory concept, okay, or shared data structure is used in the system. So wherever any machine wants to execute the task, it will take or it will share the data which is present in the shared memory unit. Okay, and that data will be used to execute the task. Okay, so basically this type of means unstructured communication is used in the parallel systems, okay, where shared memory concept is used. It is not used in the distributed system. Okay, so in some applications of distributed system, maybe the shared memory can be used. In such cases, we can say where messages are not used explicitly, messages are not transferred between two nodes or between two units or between two computers. In such cases or in such applications, unstructured communication is used. Okay, and second is structured communication. So structured communication is basically message passing. Okay, so the machines or the computers which are having their own CPUs and memories, it means data is distributed among all the network, among the all computers which are present in the network. So in such cases, data communication, or we can say the data transfer is required. Okay, so that data is transferred in the messages. Okay, so basically where message passing is used, we can say that is what the structured communication. So structured communication is mainly used in the distributed system where shared memory concept is not there. Okay, memory should be distributed among different computers. So shared memory concept shouldn't be there when you are using structured communication. And if shared memory is there, that is maybe the example parallel systems, there you can use the unstructured communication. Then overview, what we are going to see in this particular chapter. So we are going to see the message passing protocols. These are the basic protocols: layered protocol model, OSI reference model, and client server model. And then higher level communication models, which are exactly or actually used in the distributed system applications. That is remote procedure call, RPC, remote method invocation, that is RMI, then message oriented communication, stream oriented communication. These are two types, or we can say the types of communication based on the how or what kind of data you are going to transfer. Okay, that is message oriented communication and stream oriented communication. And last one is a remote communication. So message passing protocols are the basic protocols. These protocols are the basic protocols used in the any models, and these higher level communication models are specifically used in the distributed system applications. Okay, so we'll see first, that is open system interconnection model, that is OSI model. This is the basic model for used for the communication. Okay, so this OSI model identifies and describes the issues involved in low level message exchange. Okay, so as I have told you, in basic models this OSI is used. That's why it is said in low level, wherever low level message exchange is required, uh, uh, and the issues related to low level message exchange are identified and resolved in the this model. So it divides, this particular model is divided into 7 levels, or we can say it 7 layers. And it is the these 7 layers are from most concrete to most abstract. Okay, so each layer provides their interface, right? Each level or each layer is having their own operations, and we are going to see that in detail. Then the each layer provides the supports for the communication between the systems, two systems. Okay, so this is basically the layered protocol model, or we can say the OSI model, where the layered protocols are used. Why this is called as layered protocol model? Because layers are there. Okay, different layers are there, sequential layers are there, and the communication should carried out through each layer. It will not be the case that you can exclude one layer. Okay, or data may get transferred from one layer excluding in between layer and directly to the third or fourth layer. Okay, so sequential communication is there. So whatever message you are going to transfer, that should transfer through all the layers. Okay, and that sequence of levels or layer should be same, or it should be defined. Okay, so we in OSI model, or in this layered protocol, there are 7 layers. You can see, you have already seen this particular OSI model in the computer networks, but just I'll give you the overview, as this is going to be used in the distributed systems as well. So first layer is a physical layer, second is a data link, then network, transport, session, presentation, and application layer. Okay, so now we can say this is one system where these 7 layers are present, and this is another system. Okay, where this that particular system 7 layers are present. Okay, now communication is going to happen between these two systems, system 1 and system 2, we can say. Okay, so communication happens here in each layer. Okay, and we'll see what kind of communication happens there. Okay, so firstly this application layer is there. In application layer, application protocols are used. This is the highest level of layered protocol or OSI model. Okay, application layer provides the, we can say, interface to the user, and user can use this particular interface to interact with the system. Okay, then this is the high level protocol. When user uses the interface and submits the task, it then comes to the presentation layer, that is sixth layer of layered protocol, presentation layer. So presentation layer creates the messages, or we can say string of bits. Okay, it actually responsible to create the messages, and then presentation after that presentation layers message, will get forwarded to the session layer. Now what is the duty of session layer? Session layer is responsible to establish the communication. See, if you want to communicate with another system, or if you want to submit the task to the another system for execution, you cannot directly send the message, or you cannot directly send the task for execution. What we have to do, we have to first do the communication that I want this type of message transfer, or I want to shift my task to this particular machine or that machine to execution, for execution. And we have to take the permission from the another machine, or first machine needs to take permission from the another machine. This is what called as establishing connection. Okay, and after getting this permission, the message passing or task passing is done, or task gets transferred to the another machine. Okay, so this particular communication establishment is a duty of session layer. Okay, then fourth is a transport layer. After session layer, that message, or we can say the task gets forwarded to the transport layer. The transport layer creates the packets. Okay, and actually those packets get transferred through the network. Okay, message packets have been created at transport layer. Then task comes to the, or that packet comes to the network layer. Network layer is responsible for the establishing a connection, actual physical connection. Okay, means routing, which route should be feasible for the communication, or it calculates the, what we can say, the better route. Okay, so this is the duty of network layer. Then data link layer, it adds the header or footer tags, or it adds the checksum. uh, it is responsible to maintain the, we can say, confidentiality of data or integrity of data. So it adds some things like checksum, or some mechanisms are used at a data link layer, so that after passing that data to the another machine, the check is made whether the same data has been received or not. Okay, so that has been taken care by the data link layer. Then comes is a physical layer. So physical layer, it is responsible to transmit the data. Okay, so actually in physical layer, your communication links are used. So data is transferred in terms of 1 or 0, that is in signals, right? So copper wires, or fiber, or any wireless network. So this is the duty of physical layer. So this is the working of layered protocol. Then we'll see how, where the headers are actually, we have seen what are the duties of this each layer, but actually the headers are added to each layer. We'll see this is the actual message by the user. Then at application layer, application layer, header is added. Then at presentation layer, presentation layer is added. Then message comes to the session layer. At that time, session layer header is added. Then message comes to the transport layer, so transport layer header is added. Then it comes to the network layer, packet. So packet, then network layer header is added. And at last, a message comes to the data link layer. So data link layer header and data link layer trailer is added to the message, and then it is converted to the bits in the physical layer, and then those bits are actually get transferred on the network. So this is about layered protocol. Next point we'll see in next lecture. Thank you.